Well, hi there. This is lessons 44 through 49 of Algebra 1. Doing a lot of lessons this week on one video because I'm going out of town. So here we go. Lesson 44 is not that complicated. Do you remember this? 2/7 plus 3/7 equals 5/7. And that's how you add fractions. Great. Now we're going to do algebras. What's the trick with adding fractions? Well, when the denominators are the same, you just add the numerators. 2 plus 3 is 5. If I have something like 2/7 plus 3/5, I can't just add them. I have to make the denominators look the same. And so in this case, I'm going to multiply top and bottom by 5. This one, top and bottom times 7. And so I end up with 35 as the denominator. And I end up with 10 35ths plus 21 35ths equals 31 35ths. So you must have the denominators the same to add them. Pretty simple. Well, sometimes the denominators are not numbers. We are in an algebra class, so yes, you're right. You got it. It's going to be letters. So let's say I had something like this. 5 over a squared plus 7y minus 3 over a squared plus 7y plus z over a squared plus 7y. First thing you say is, can I do that? And the answer is, of course you can do that. The denominators are all the same. So whatever my answer is going to be, it's going to be a squared plus 7y. And then I just add the tops. Well, what's 5 minus 3? Well, that's 2 plus z. And that's the answer. That's as good as it gets. So you must have the same denominator to add fractions just simply across the top. If you don't, you have to make the denominator the same. So let me give you how that might work out. Start with something a little bit less complicated than a squared plus 7y. Let's look at this example. Let's say you had a problem of 3/4 plus 2 over b. And you say, well, how do I add those? Well, first of all, your brain says, oh no, there are letters, and don't care. Do the denominators look the same? No, they don't. How can I make them look the same? What if I multiply top and bottom times 4, and I multiply top and bottom here times b? Now I have b times 4, oh no, yeah. So my denominator is going to be b times 4. Normally we put the number in front of the letter. So b times 3, or 3b, plus 2 times 4, which is plus 8. That's the answer. So that's how you do it. You add fractions the same way we've always done, but if there are letters in there, you just make them look the same and do whatever they tell you to do. Let me give you another example. Let's say you have 4 over b plus 1 over c plus 1/2. Okay, can you add those? No, because the denominators are not the same. So let's make them look the same. Well, this one has a b, this one doesn't have a b, so let's give it a b. This one also doesn't have a b, so let's give it a b. All right, so now this one has a c and a b. This one doesn't have a c, so let's give it a c. This one also doesn't have a c, so let's give that one a c. Again, multiply top and bottom times c. Now it has a CB, and a BC, which are the same. It needs a 2. So let's multiply top and bottom times 2. So I'm going to end up with 2, and generally we go alphabetical order. B, C is the same in all 3. And we have 2 times 4 is 8, so I have 8C, plus 2 times 1 times B is 2B, plus BC. That's the answer. Remember, in adding, you can't add different things. So you have 8 cats, 2 boys, and a boy cat. I don't know what that is, but you can't add them unless they are the same things. That's how you do it. And that is your lesson. So congratulations. You'll have a bunch of problems like this on lesson number 44. Now let's go to lesson 45. All right, lesson 45. Okay, lesson 45 is introducing you, or actually it is reminding you of these three words: range, median, mode, and mean. Okay, so let's start with the ones that you know. Mean. It is mean to call someone average. Everybody wants to be swell. Mean just means average. And you should know how to find the average is you add all the numbers or add all the data and divide by how many. And that's average. That's, again, a reminder. Now, let's say you have a bunch of data, a bunch of numbers that you're trying to figure out. What's the range of this data? What's the median of this data? What's the mode of this data? What's the mean of this data? These all have value in statistics, and they have value in trying to figure out stuff. I used it a lot in my business as a principal to try and figure out how to make sure that I wasn't... I could afford to pay all my teachers. So what was my average pay, and then what was my total pay, and what was the range of pay? So I didn't want somebody making $90,000 and somebody else making $40,000 for the same job. So I had to keep my range low. I had to make sure that I could afford it. When I was comparing, are my teachers going to be wanting to be here? They're going to look at, well, what's the average teacher or what's the median teacher in another district? So if you could get paid 40 grand more in another district, why would you come and work for me? So all of this stuff I used a lot in my business, and that's just not even teacher pay, but we use these concepts. All right, so I'm going to give you some a fake set of numbers, and let's pretend this is I don't know, a bunch of kids, and they have a bunch of marbles in their lunch boxes. And so one kid's got 8, another kid's got 10, another kid's got 14, another kid's got 30, another kid's got 30. Okay? So let's figure out with this data, what are all these things? Well, the range. Let's start with that. The range is low to high. Okay? So for example, the highest number is 30. The lowest number is 8. The range is going to be 22. In other words, it's from 8 to 30 is 22, or 8 plus 22 is 30. So you can say 30 minus 8 is 22. Doesn't really matter. It's what's the difference between those two. That's the range. Okay. The median. Okay. The median is the middle number. What's in the middle? Well, there's 8 and 30. There's a 10 and a 30. The middle one is 14. Okay? That's the median. The mode, everybody remembers this. MO stands for most often. In other words, which one has more than anything else? Well, there's one 8, there's one 10, there's one 14, but there's two 30s. So the mode is 30. And the average, well, that's add all the numbers. 8 plus 10 is 18, plus 14 is 32, 62, 92. So it's 92 divided by 1, 2, 3, 4, 5. That's going to be the average, and that's going to be 18.4. If you did that in your head, great. If not, use a calculator. So that is how you do it. The only thing that I haven't really covered is what if the middle number, there is no middle number. So let's say, for example, this one only had 130 instead of 4 of these, and I wanted to know the median, the middle number. There's no middle number. There's an 8, there's a 30, there's a 10, and a 14. There's no middle. The middle would be here somewhere. So what you're doing here is you're splitting the difference. In other words, what's halfway between those? So the middle number in this case would be 12, halfway between 10 and 14. And if it's a fraction, it's a fraction. If it's a decimal, it's a decimal. If it's a whole number like this one, it's 14. Essentially, you're finding what's the average or what's halfway between 10 and 14. To figure that out, you just say 10 plus 14 divided by 2, and that's going to be 24 divided by 2, which is 12. If there is a middle number, you just use that middle number. But if there's not a middle number because there's an even number of data, you have to do this little find the average between those two. That is mean, median, and mode. If you get a bunch of data, always start with putting them in order. That allows you to figure out what's going on. 8, 10, so, go up. Don't just have them mixed up. It's hard to find the middle number when they're mixed up. And that's lesson number 45. So let's move on. Lesson 46. We get into quite a bit more algebra as the year goes on. You're going to see it starting to get a little bit more complicated and a lot more concepts going on, and you're going to have to keep a lot more in your head, but we can do it. All right, so let's use this thing called conjunctions. Conjunctions. Most people don't remember that name, even math people don't. Then you say, hey, what's the conjunction? What they mean by this, when they talk about conjunctions, in this lesson especially, is they're just saying visualize what's going on here when you've got more than one thing going on. So, for example, I'm going to Costa Rica this week. We're going to be teaching kids self-defense for a little jungle tribe called the Bribri. And yes, that actually is going to happen. But I know that my kids are going to be, I'm going to say K for kids, they're going to be younger than 18. And I also know they're going to be older than 9. So what ages do I have? In other words, you have two things going on. What's the conjunction, or what is the combination of those two things together? Well, if I draw this on a number line, and I just put random numbers here, I'm going to put 18 is here, and 10 is here, 9 is there, and 0 is here, and going on. If I say they're younger than 18, to draw this on a number line, I would put this as a open dot and an arrow this way, right? If they're older than 9, I would say it's an open dot and it's an arrow that way. So if I say, what's the conjunction? This is how I would draw it. Open dots at 9 and 18, and then a solid line in between them. That's the conjunction, or the combination of both of these things. I could write it like this, or I say it's this and this, or I could write it as K is less than 18, but is greater than 9. This would be another way to write this. Drawing's a little bit funky there. And that's what this lesson is how to take this information, turn it into this, and draw that. Another example would be, for example, some number is going to be greater than -1, but it's going to be less than or equal to 5. So how would I draw that? Well, what I typically do is I just put the numbers here, and I don't bother with any of the rest. So if I know it's greater than -1, it's an open dot, and it's going that way. And if it's less than or equal is a closed dot, and it's going that way. That's the answer. That's all you have to do. So this would be the conjunction in drawing it. How I would write it is x is going to be kind of how you have it here. See how x is on the left and the negative or less than or equal 5 is on the right? Do it that way. Here, x is on the right. So this one's a little bit harder. X is going to be bigger than -1. So I have to kind of write it flipped around a little bit. So I'm thinking it's either this one, which is another way to write that one, or it's this one. And you keep the letter in the middle. And that's how you would write it. And that is lesson number 46. Okay, lesson 47. What is the concept in 47, you ask? Well, let me tell you. 47 is talking about this idea. Blank of blank is blank. Now, you've done those before. Of means times, is means equal. So, what is this? When we talk about percentages, this one is all about percentages that are either bigger or smaller than 100. For example, we would say 20% of what number is 15? Okay, so something of something is something. Okay, the way we would write that is 20%, which is 0.2. Of means times. What number? We always just throw an X, whatever says what number, is equal 15. So if I were to figure this out, divide both sides by 0.2, and I get X equals 15 divided by 0.2, which is going to be 75. Okay, and you can do that with your calculator. And so 20% of what number is 15? The answer is 20% of 75 is 15. In this case, you're just using your calculator to figure this out. Now, there's also a concept in this book because I want you to visualize that thing. So if the whole number is 75, this is kind of a way you could draw this. You could say 20% is 15. If the whole is 75, well, what's 80%? Well, it's going to be whatever 75 minus 15 is. That's going to be 60. So there's a new thing that we're adding here, is we're having you visualize stuff. So 20% of what number is 15? This is, well, 20% is 15. So 20% of 75, that's the whole number. And you could also figure out, well, what the other part is too. 80% is 60. So that's the first thing that you're doing with this lesson is visualizing. So let me give you an example of an exact problem you might see in homework. This will be practice problem A. That'll work. Practice problem A. It is, now let me give you a different one. Yeah, no, practice problem A is fine. 20% of what number is 800? Okay, so again, I'm going to write 0.2 x equals 800. Divide both sides by 0.2. I get x equals, you take your calculator out and you say, well, I don't know, 20% of what number is 800? So that's going to be 4,000, I believe. Double check that with my calculator. It happens when you do it in your head. So you just say 800 divided by 0.2. Yeah, 4,000. So that's the answer. Now, the question says, work each problem, then draw a diagram for each problem. Okay, the whole thing is 4,000. That means 20% is 800, and 80% is going to be 3,200, because 800 and 3,200 equals 400. So this is the drawing the diagram that goes with this. That's all there's to it. That's the first half of lesson 47. Let's go to the second half of lesson 47. The diagram part is really the only part that looks a little funky on the second part. It's a little different. So here's an example of a problem. It says, what number is 160% of 60? Well, this one, again, is what number is x equals 160 is 1.6 times 60. So you just do the math, and you say 1.6 times 60 equals 96. Okay, and use your calculator. It's fine. And so the question is, well, what number is 160%? Well, 96 is 160%. So in drawing this, you would say, well, the whole number would be 60. And then this would be kind of the big concept, is you'd say, well, 96 is 160%. So it's bigger than the basic number. 96 is bigger than that. So the drawing the diagram is, if a regular whole thing is 60, 96 can be much bigger than your regular whole. So you usually draw it in some version, and your book does it as kind of like a double bubble with it squeezed in the middle to show that it's more than just a single bubble. And so that's how you would write it. Pretty much this is the answer, this is the visualization. And again, when they say of this number, of the number, that's the of is the big number. Okay, and that's lesson 47. Lesson 48, you ask, what is going on in lesson 48? Well, good thing I'm here, because I'm here to tell you. Lesson 48. Lesson 48 is all about recognizing this new concept, and it's called polynomials. Okay, we've been doing algebra up till now. We're going to shift into this thing where we're focusing on a single variable. So, for example, x, or 2x, or x squared, or 3x squared, or 5x to the fourth. Okay, these all have one thing in common, and that is x. Also, it could be, basically all those work. Also, just a number, 7. Okay, so regular numbers fit into this thing called nomials, just means numbers. Poly means there's lots of different kinds. There's actually kind of rules. What is a polynomial? For example, is 4x squared plus 3y a polynomial? The answer is no, it is not, because these are different. But is 4x squared plus 2x minus 7 a polynomial? The answer is yes, it is, because these all have the same one, except and a number. The old and a number, or 5x to the fourth plus 2x. That's a polynomial. It doesn't have to have a number. These, yes, are polynomials. This, no, that is something else. So that's what this lesson is what is a polynomial? It's a letter or some exponent number version of the letter adding together. They're all kind of the same. Why this works, what the names are, that's what this is talking about, names primarily, and kind of how you look at them, not so much what do you do with them. That is later. So let me give you a little bit more on how to name them. Again, we'll focus on what to do with them later, but you kind of need to know the names. So if there's one of them, we call it a monomial. For example, x to the fourth. If there's two of them, we call it a binomial. Again, bi means 2, so x squared plus 7. It's a binomial. If there's 3, we call it, you guessed it, a trinomial. Like 3x squared plus 2x minus 4. Okay, and that's the name. And if there's 4 or 5 or 6 or 7, we just call them polynomials. Because poly means many. But when we just talk about, you say, okay, this is technically it's a polynomial. Think of it as like it's in the family, all of these are in the family of polynomials, but we just call this thing, these are the ones that we actually kind of give names. and we say the 2 are binomials, the 3 are trinomials, we usually just say it's a thing. It's a x to the fourth. We don't bother giving it another name. We just look at it and use it. When there's 4, 5, 6, or 7, we just call them polynomials. But these you should know. All right, so also you'll notice the way I wrote these. I started with the highest exponent, and then I worked my way down, and the numbers are last. So if you had a pile of these things, and you were to say, okay, put these in order, and I had an x to the fifth, I had a negative x, I had a 6, I had a 3x to the fourth, and I'm adding these things together. This would be a minus, forget that. And I said put them in order, it would go x to the fifth plus 3x to the fourth minus x plus 6. So it'd always go in order of these things. And that's kind of the normal thing you would do, and you want to get used to doing it that way, not just putting them in random orders. It's the high ones are in first, and then the rest go afterwards. Last thing that goes with these, a little bit of, okay, what can you do with them? It's not that complicated, but let's say you have an x to the third plus 3x squared plus 2, and you're going to subtract 2x to the third plus 4. Okay, well, how do we do that? And the answer is, well, we can only add and subtract things that are the same. Remember, a cat plus a cat equals 2 cats. A cat plus a dog is a cat plus a dog. You don't get a cat dog. So in this case, I'm going to rewrite this without the parentheses. It's x to the third plus 3x squared plus 2, okay, minus 2x third. And I use the distributive property minus 4. So now it's a little bit easier to see. I have an x to the third, and I have another x to the third. Okay, what's one of these minus 2 of those? It's a negative x to the third. And then I have a 3x squared. And then I have a 2 minus a 4, which is minus 2. So I just kind of start with the top, get all those, done. Start with the next one, get all those, done. Start with the next one, get all those, done. That's why putting them in order really makes a big difference. And this is the answer. So you may have only add terms that are the same. Also remember, if you have a negative in front of something in an exponent, basically, so let's say you had 3x squared plus 2x minus 9, this becomes negative 3x squared minus 2x plus 9. Remember, this negative, basically negative of that, negative of that, negative of that, or opposite of that. And so you distribute that negative throughout. That's lesson 48. Now lesson 49 has more polynomial stuff, and it's basically getting you to remember how to use the distributive property for only using letters instead of not letters. So for example, if I had 3 times 2 plus 5, it would be 3 times 2, which is 6, plus 3 times 5, which is 15. I would distribute this times this times this. Well, what if I have 4x times x squared minus 2? Well, 4x times x squared is 4x to the third. Remember, and 4x minus 4x times this is 8x. So that's going to be important for you to look at, is that you remember your distributive property rules, but it's just this. As you're saying, this times this, that's that one. This times this, that's that one. And that's the rules. Okay, now what if you have something like 4x plus 5, and you'll start to see these a lot as we move forward. 3x minus 2, like this. Well, if you have something in parentheses here times something in parentheses times there, what you do is you say this times each of those. So this times this, 12x squared. This times this, minus 8x. Okay, that takes care of this one. Then you do this one. 5 times this, it's 15x, and 5 times this, minus 10. So now that's all of them. So basically you pretend the other ones don't exist. And then you just work your way around. There's one little step here. This is an x squared, so the answer is 12x squared. Now I have a negative 8x plus a 15x. Well, that's 7x, because those are the same, minus 10. And that's going to be my answer, because I do need to combine these at the end. And that's going to be typical. You will have that. Let me give you one more. So if I went a little fast, I'll talk your way through it. And again, this is lesson 49 now. Give you an example of one of your practical work. You have 5x plus 3. This is practice problem A times 2x minus 4. Okay, you pretend you can't see the 3. And you say 5x times 2x, that's 10x squared. 5x times negative 4, minus 20x. Now you pretend you cannot see the 5x, and you're only looking at the 3. So 3 times 2x is 6x. And 3 times 4 is 12. Okay, so I'm going to end up with 10x squared. I have a negative 20x plus 6x, which is minus 14x, because they're the same, plus 12. That's the answer. That's how you do these. That's lesson 49. Why we do these, we'll cut to later. But enjoy. I will see you in a couple of weeks.